Right, can you see that okay?
Yes, that's great.
Yes, fantastic. Okay, so I was given the title How to Do Good Alt Text, which is quite vague, but quite important. So I've included a subtitle called Describing Maths When You're Not Really a Maths Person. And that's basically me. I'm not really a maths person. My name's Huw Alexander. I run a company called textBOX, and we focus on describing images. Basically, I describe images all day, every day for my living. I work with publishers, with universities, whoever may need my help. And today we're just going to be talking about maths and stats from a very layperson point of view. I'm going to talk about graphs and structure, then equations and the limits of alt text, and finish off with presenting data and including some resources along the way. Now, I got a grade B in GCSE maths, so I'm feeling quite intimidated amongst you all. There's over 100 people, I think, in the room. Every single one of you is probably better at maths than I am. So forgive me if I have any mistakes, but I'm kind of trying to balance out that lack of expertise with a kind of sense of curiosity. I kind of like maths. I might not be brilliant at it, but I do like it. And I do a lot of research to explore maths and stats and how to actually describe it in a way that's understandable and helps people visualize that kind of content. Now, these are some of the books I've worked on over the last year. Statistics for people who think they hate statistics was a good one. Discovering Stats using IBM SPSS statistics was a 1,200-page textbook with 3,000 images in it, and I needed to sit in a darkened room afterwards. And things like scale development and research methods. So all of these books bring in that kind of mathematical aspect, whether it be graphs and diagrams or equations. So I've developed Focus Locus, which is basically an accessible method for accessible images. And essentially, it breaks down those images into their constituent parts. You start off with the focus element, the main subject of that diagram, and then you develop around that the locus elements, which are the details. So, for instance, with a bar chart, you've got the X and Y axis, you've got the data labels and the data points, which need to be described in turn as lists or tables. So you're breaking it down into its elements. So if you think about any kind of graph, it probably came from something like Excel, and originally that graph was a data list or a data table. So you're taking it back to those original elements. Now, the Focus Locus approach basically breaks down into scene setting and storytelling. So initially you have an overview, which is kind of like the alt text. You're introducing that image, and generally with a lot of complex images in maths and stats, it will be a longer description will be required. So you're introducing the image using the alt text. You're providing a structural description. Now, this is something that's often missed a lot by in the alt text and long descriptions that I see. A structural description is really necessary in terms of helping the user to visualize that content. So again, with that kind of bar chart, you're talking about the X and Y axis and how many data points and the range on the X and Y, and just to facilitate that kind of visualization. And then you're talking about the main subject of the diagram and the details within it, and that's the storytelling element. So you're creating a pathway through that diagram or image. You're setting the scene, and then you're telling the story, and hopefully creating a kind of immersive experience on the way. So let's have a quick look at graphs and structural description. So this is an example of a line chart from one of the books I've worked on recently. The alt text for this is a very simple line chart. Alt text says an example of a hand-drawn cumulative frequency distribution chart. And then you have that structural description, which I talked about, which is the class intervals are plotted on the x-axis, the range from 0 through to 49. And I have to move the video over a bit. There are 10 class intervals. The cumulative frequency is plotted against the y-axis with range from 0 to 50 at intervals of 5. So essentially, you're creating that structure. The person listening to that description is thinking, I know what's on the X and Y, they know what to expect. And the resulting line describes an S shape, just to give them another visual aspect. And then we're introducing the data point as a table in the long description. So the user can actually interrogate that information independently. They can get through that table and find out the individual data points. Similar kind of thing with a histogram here, example of a hand-drawn histogram chart. Class intervals are plotted along the x-axis, the range 0 to 49. Histogram chart contains 10 bars. So again, you're managing expectation. You're not kind of just leaving the user hanging in terms of how much information is going to be presented in this chart. There's 10 bars with class intervals, frequency, and midpoints. 10 midpoints are represented by an upward facing arrow plotted on the x-axis. Frequency is plotted against the y-axis with a range from 0 through 10 at intervals of 1. And then again, a table is introduced to present all the data points. Finally, in the graphs, these are distributions. So a series of 3 distribution graphs illustrate how distributions can differ in degree of skewness. The values are plotted on the x-axis, frequency on the y. Again, there are no data points on either one. So again, you're providing that structural description. And 3 distributions form bell curves. Left end of the x-axis labeled as low score and the right end is high score. And then you're just describing each one. So distribution A has a right tail that is longer than the left tail. And distribution B is a standard bell curve. Distribution C shows negative skewed distribution. So again, the user can step through that list and really get an understanding of each element. Now, equations can be quite challenging. This is special relativity. Everyone knows this one, equals mc squared. I use something, a lot of publishers that I work with MathML, which is fantastic. All the equations are already done. But sometimes there'll be a diagram with equations embedded into the diagram. So as part of that long description, I'll write the equation. So I use something called MathSpeak, which I'll link to there, which has a whole series of grammar rules, which is fantastic. And it takes a little bit of time to learn, but it's really useful for describing equations correctly and accurately, which is the main thing. So that E equals mc squared becomes upper E equals mc superscript 2. So fairly straightforward. It can get a bit more complicated. This is chaos theory, which is x subscript p plus 1 baseline equals kx subscript p. And you get the idea. And you can see that's a fairly short equation, so they can get quite lengthy, but it can be quite challenging. So if XML or MathML is possible, then I would thoroughly recommend it. But I do find MathSpeak to be a very useful way to convey equations, mainly because it's so important to be accurate. It's OCR, if you OCR a PDF, generally there'll be a mistake in that equation. The subscript will become just a normal standard number, and it kind of ruins the whole equation going through. So you have to be very careful with OCRing content. Again, this is an example of a diagram with equations embedded into it. So you're starting with your text, giving an overview of that diagram, explaining in relation to the caption, and then talking about it being a cutaway section with 3 spheres, and then providing each sphere and the equation for each, and each equation is written in MathSpeak. Now, I'm inserting a commercial break here. I have no connection to Equatio at all. I've used Equatio on occasion, but it seems to be quite a good program for translating equations into digital. So I thought I'd pop that kind of reference in there. It seems to be that there's some kind of free aspect for teachers, which is probably worth exploring. But anyway, just a reference just in case. Presenting data. Now, data tables, I do a lot of work with the United Nations, for instance, who provide reports with loads of data. Wonderfully, they actually provide me with data tables. As I said before, a lot of graphs and stuff, they come initially from data in Excel, and they provide me all the Excel spreadsheets, which I can then use to create tables for the descriptions. But generally, when I'm looking at textbooks from publishers, they don't tend to include even data labels on their graphs, which can be a challenge for blind users and for sighted users. It's sometimes very difficult to estimate what the data points are. So just kind of referencing the fact that it's always good to include data labels in your content. And things like this on the right-hand side here, there's the 100% stacked bar chart. And these kind of the bane of my life in a way, because they're really difficult to estimate the data labels on them. If you're looking especially at the middle value, you're thinking, is that 25? Is that 27? Very difficult to estimate for any user. So always providing data labels with graphs and bar charts, pie charts, anything like that, always really, really handy. And data table structure, I think I'm preaching to the converted here. Everyone knows about tables, but having a good table structure, a simple table with column headings and row headings really makes a difference. Tables are really screen reader user friendly in terms of the screen reader will announce you're in column 1, row 1, and the user can independently jump through that table. And especially if it's a really large table. I've done tables that have been like pages long, and if you only want a subset of that data and you want to jump through to it, very difficult to do that if you present it to the list. So if you present it as an accessible table, the user can actually go directly to the data they actually want. But make sure it's simplified, no merging of cells, no split cells, and that there's column and row headers. I'm going to kind of finish up with, I think because we're doing time, we're doing all right for time. Wow, the first time in my life. Maths and Greek. Now this is a class diagram. I actually did the description of this. It was hellish. I had to do a lot of research. And it's difficult enough when it's mathematics, I find, and flowcharts and kind of path diagram, trying to feed all this amazing information into a kind of understandable format. But then they make it and label it in Greek, which makes it really challenging. So I'm not a kind of ancient Greek speaker. I don't recognize all the different symbols. So what I actually use is something called the Physics Hypertext book, which is a free website. The link is at the bottom there, which basically is, I think it's just one page. Well, the main bit that I use is one page, and it's a long, long scrolling list of every single mathematical, physics, chemistry symbol that can possibly ever exist in the entire world. I go through that and find out exactly what all these symbols actually mean. So I've just found it really, really helpful. It's free, and it's a really good reference guide. For instance, this is some screenshots from the site, so you can see all the Greek alphabet there, all the symbols, and various kind of functions on the right-hand side. So just to say that this kind of reference material is out there, and it just proves very handy if you can't quite identify some of the symbols used in equations or diagrams. Now, just some final thoughts. Putting all this together in terms of providing data labels, making simplified accessible tables, equations, describing those graphs, providing structural descriptions, really helps with visualization. That's the main thing. So the user can immerse themselves in that description and really get a sense, and really recreate it in their mind of what that content should look like. And also it kind of promotes that independent exploration of that content. You can jump through that equation, really understand it. You can jump through that data and really get the kind of information that you need. And I just want to make one final point. Everyone asks me about AI at the moment and whether it's going to be the end of my job, which is a nice conversation. But I didn't really want to talk about AI. I've seen a lot of work being done by people at the moment in terms of creating interactive charts ways of working with data. Maths is all about rules, and that's one of the wonderful things about it. It's organised. So I do see a real bright future for creating interactive content, which users can step through, whether they're sighted or visually impaired, to learn and actually interrogate that information. I think Professor Sorge will probably talk about that in his section, but I see a real great kind of excellent kind of things happening in that field. So I think there's good things coming in the future that will make kind of accessible maths even better in the future. So perhaps we won't need as much alt text. People will be interact with that content just as well. So fingers crossed. Anyway, that's me. I think I almost kept time again. So forgive me if I went over.
Absolutely bang on perfect, Hugh. Thank you very much for a great talk and lots of tips, lots of food for thoughts for us all in the community. Good times for question. Ginny, I don't know if you saw some questions in the Q&A. I can't see any questions in the Q&A, certainly some in the chat. And I think, Dad, your question was first about alt texts for plots and whether we have any good guidance for scatter plot. So I guess this would be a question for you. If you want to come in, you.
Any guidance for scatter plots? Yeah, they can be a little bit tricky. I kind of call them mass data. Generally, they've just got this whole sea. We saw some examples just then, a whole sea of different plots on there. Providing them as a data table, I think it's a good idea, but it's going to be a huge table, but it will actually facilitate that kind of independent learning. I generally provide that structural description, the alt text, and a trend, just to outline the kind of trend line within that data to say what's actually happening, and then provide the full data set within the data table, if available as well. Sometimes if you haven't got that data set as kind of backup, it's really impossible to sit there and work out the coordinates of 100 data points. So I wouldn't recommend that. So I would just stick with the trend line and what the author of the piece is trying to convey that information. So that mass data can be mainly about trend information, but if the data is available, I'd provide it as a data table if possible. If you're thinking about it in terms of describing it as all text and long description, otherwise I'm sure there's fantastic ways that with charts, and I think high charts have done something with scatter plots where you can jump through each data point, but again, it's quite overwhelming in terms of if you've got 100 data points, it's a lot of information to take in, so and kind of influence cognitive load and things like that. So mass data can be a challenge. So definitely worth including trend information.